So we've been practicing this regression, doing the regression thing and domain and range. Why is that? Because quite often you will be presented with a situation where you don't have an equation, but you do have some points. So guess what? You're going to have to come up with the equation. Guaranteed. If you see points, think regressions right away. Okay? If you get the equation, don't worry about regressions because you have it, right? You have the equation, no big deal. But quite often you'll be presented with a scenario where you have to come up with regressions. So that's one on one side. On the other side, every question, every quadratic has a domain and range. Every quadratic has a domain and range. How so? Right? I don't want to write on my study sheet right now, so I'm just going to use this. We started off with general quadratic functions, right? Where whenever we graphed, we were considering everything, all four quadrants, right? So all of these had negative infinity to positive infinity for their domain, right? Now, when you have a word problem, we're often going to say, well, no, we don't care about the whole thing. Our calculator is going to show us the whole thing, but more often than not, we're going to start here and we're going to end here, okay? Or there might be a scenario where you won't even touch the x-axis. Like, you won't consider it because something is thrown and then lands on a surface, let's say, off the ground. So we're kind of just restricted to this scenario here. So the reason why we have a domain and range for every situation is so we can kind of like box this in. It's like, no, we don't want to consider this tail or that tail. We just want to stick to this domain and range here. This is where my action is happening. It's restricted to just this little stretch here of the entire quadratic function. Okay, so this is where we started. So in general, there should be infinities somewhere in general. But once we start talking about a word problem, you shouldn't have infinities really. Every once in a while in grade 12, you will have some infinities. How so? When you're talking about money and investing, you start with a certain amount and your investment grows. If the question doesn't say that this ends, technically your money can grow indefinitely if you just leave it there, right, in the bank. So then sometimes you'll have some infinities. So keep that in mind. I want you to have the end in mind before you even get started, okay? So that is kind of like in the background of everything we're doing, okay? So 49. I have 4 types of regressions that I'm going to, technically there are no types, but I kind of have them in 4 types. Type 0 is the one where I give you the points. Types 1, 2, and 3, you will have to create your own points. So today we're just going to start with type 0, where the points are provided. This is probably one of the most common one. Okay, so type 0, points are provided. So let's read this question. An airplane performs a stunt at an air show. It consists of a sudden drop followed by a rapid increase in height. So you're dropping and then you're increasing. Oh, it looks like a parabola. Or a smiley face, I don't know. The stunt ends when the plane reaches its initial altitude, height. The table below shows the heights at different times. So it's, maybe this one should get a different color, this part right here, because it gives us an indication that this thing ends. It ends when the plane reaches the initial altitude, the initial height. Okay? So basically, we're now saying that it starts somewhere and it ends over here. So that's where it stops. Even though we know the parabola continues on our calculator, we're going to put a stop to it right there. And it's going to be at the same height as when the stunt started. Okay? So it will start here, the stunt starts, the plane drops, reaches the lowest point, comes back up, and that's when this thing ends. That's the only section of the parabola we're interested in. Okay? Does that make sense? Okay. So then we've time and height. And remember, I told you that if you have a horizontal table, we always assign x to the first, y to the second. This is true in grade 12. Okay? This is always true. And so immediately you should be like, oh, I've got points. I'm going to put that into L1 and L2 at some point. A is asking, determine the equation that models the height of the plane over time. We're going to do this. We're going to go stat, calc, quadratic regression, and we're going to fit the equation here somewhere. Okay, so let's go ahead and do that. Stat edit, clear, 2, 6, 8. By the way, these do not always go up by the same amount. So don't be thinking, oh, 2, 6, right? Like it will be random. Quite often it's just random increases. So be careful. Then it's 750, 315, 210, 433.13. So that's weird, right? All of a sudden you got 2 decimals there. If you don't have the same amount of entries, you're gonna have a problem. Watch, if I try to do my regression, it's gonna say dimension mismatch, right? You don't have the same amount on both sides, so go and investigate. If you select go to, it's going to say Y1. It's not really what the problem is. But yeah, I forgot the 433.13. Okay, so you've got the points. You could do the quad reg again. I'm going to quit this. I already pasted it here. I'm going to rerun it and write down this thing. Okay, so Y is equal to 9.338 technically, minus 183.75x plus 1080, and this technically rounds to 0, 0, right? So I don't know if I told you this, but even if it's 0, 0, like if there's a bunch of zeros, the province would expect you to round to 0.00 because you are truncating, you're cutting. So if it had been exactly 180, you're fine. But as soon as you have to cut, you have to put 0.00. I know it's annoying, but that's what they told us just this last semester, okay? All right. So this is A. A bit distracting. So the initial height, what's the initial height of the plane at the start of the stunt? Initial height, you should be thinking this happens at time 0 seconds, okay? Which is for us the y-intercept. You have a choice. Do you want to use your calculator, or do you just want to read it off of, this is in general form. So when it's in general form, we know that this last number is our y-intercept. So this is 0, 1080. So the initial height is 1080.00 feet. You circle that, okay? That's the answer that you want to have there. Don't just leave it as a point. Actually write out which one is it. Even if you went arrow under it and you said this is the answer, just make sure you have units next to it. C. How long did the stunt last? How do we know that? When does it end? The stunt ends when the plane reaches the initial altitude, right? So basically, here's my smiley face again. It starts here, you do your stunt, and when you get back to that original height, that's when this thing ends. So here somewhere. How would we find how long that takes? Let's graph this thing. So grab your calculators. This should be on your, this should already be in the y equals, right? If I go y equals, it's already in there. Please leave exactly as it is. Leave it in there. I'm going to attempt to graph it. I don't see a thing, which is normal because remember your y-intercept is 1,080. It's really high up the y-axis. So let's try zoom stat. I'm going to zoom into the points. It does a pretty good job. It does a pretty good job. I still want to see the y-intercept here. So I'm going to chase the curve. I have to adjust the y-max for sure. I'm going to go window. What should this be? If your y-intercept is 1,080, then you should probably change this to 1,100 or 1,200. Oops. Let's try that. Y-max. Hit graph. Technically now you see more. I also, guys, I also would like to see, let me go back to the graph. I would like to see the y-axis. So can you check this, please? If you go window, your y-min should be something negative. So I usually go like -5 or -10. And my y-min, I also make that negative. And my default is -5 or -10. Why is that? Because I want to see my x-axis, right? That's why I changed this. And I want to see my y-axis. That's why I changed this. So these changes are almost by default. I just make them. Hit graph again. See my y-axis. I see my x-axis. I need to chase this further to the right because I want to know when do I get back to the original height. Okay, so window, x max, I'm going to go 50. I'm just going to go x max 50. It's a little overkill, but now I see the whole thing. So you're going to have to play around with the window. That's all I'm saying. So we know that this is 1,080. So we can find out exactly when that happens over here. Anybody venture to guess how I would find the point out here? That's 1,080 in terms of the y. If you know your y value, you're going to put that value into y2. So I'm going to go 1,080 into y2. It creates a horizontal line. There, so now you know exactly where the initial height is over here. So guess what? We're going to find that intersection there. So let me put this down on paper so you know what to do next time. Initial height is 1,080. So we let y2 equal to 1,080. And then we're going to go second, trace, intersect. And just so you have a little visual here on the side, I'm going to make this thing appear. Okay. And I'm going to use a red line for the 1,080. Okay. So I'm interested in that intersection. Okay. So this is the 1,080 line right there. And let's do that. Second, trace, intersect. This is another issue that you might have. I don't see my cursor anywhere right now. So I'm going to look at my coordinates. As I increase the x, this is going higher up, so that's not a good direction to go. I'm going to go try left arrow now. If I go left arrow, I see that y value decreasing, so it's probably going to come down here at some point. I'm just going to press and hold. There it is, right? So sometimes it's going to be off your screen. Just look at these coordinates as you go left or right arrow to see if you're coming closer to where you can see it. Enter, enter, enter 3 times. So this would be 19.60, 1,080. So this is 19.60, right? It takes you 19.6 seconds to get from the initial down to the lowest point and then back up. It takes you 19 seconds, 19.6 seconds. 19.60 seconds. Just circle that. That's how long it will take for the whole stunt until we kind of consider it done. Sure, the plane keeps flying after that, but we are only considering start to finish here when you get back to the original height. Okay. D, what is the lowest height that this plane ever reaches? What do I need to find to get that? What do we call that point? We call that the vertex, right? It's going to happen right here. So I'm going to go second, trace, minimum, and I'll find it. Second, trace, minimum. I got to go to the left of it, enter, to the right of it, enter, enter one more time, and here it is. I'm going to write down the whole thing so that I can use it for my graph later on. And which one answers the question? This is your height, right? This represents the height. So the lowest height is 179.63 feet. That is the one you want to circle and indicate as your final answer. Graph the scenario. I thought you'd never ask. Okay. By the way, if you don't want to see those points, you know how you turn them off? You turn off plot 1. You just go and hit enter again. If you hit graph one more time, they're gone. Okay? So if you don't like those points, that's fine. But remember, zoom stat was not going to work. Okay? Let's graph this thing. Let's label first. Get that out of the way. Time in seconds. This is height in feet. And I will do my inventory real quick here. This one is important, my y-intercept. I need this one, 1960, 1080. And I need the vertex, which is 9.80, 179.63. Okay. So this one is interesting because we don't have x-intercepts. You'll never cross the x-axis with this scenario. But you will be given enough information to be able to figure that out. Now, I look at my y values. The greatest y value that I must fit into my graph is 1080. So I will do that. So let's see what works. I'm going to try this. 200, 400, 600, 800, 1,000, 1,200. If I go up by 200, that works for me. Just use a round number. Don't use, it's up to you. Whatever works for you, I don't care as long as it's consistent. So that'll work for my y. For my x values, look at the x values. The largest x value I need to account for is the 1960. So if I go up to 20 or something like that, this will work for me. So let's try this. 5, 10, 15, 20, 25. No problem. Oops. 5, 10, 15. That's good. So I don't want you to have this scaled so small that your graph looks like this. Right? Like you want to avoid that, right? Like, sure, technically that could work, but you want to kind of use up most of your graph, most of your grid. So let's plot this. This would be 1100 right here. So 1,080 is right about there. My vertex, which happens at 9.8, 179. This is 10, that's 9, 9.8 is right about there. I'm gonna see here, this would be 100, 150, 179 is right about there. Okay, so that's the vertex. Then I'm at 1960, which is right about here. I'm gonna go all the way up to 1,080. So back to where I started. So those are the only 3 points you have, but I would argue that's good enough. Don't use a pen unless you're absolutely sure you know what you're doing. But in this case, I will use a pen. So you go like this. Always use a pencil. It's just so much safer. But Mr. Rickson, is it okay if I do this? Like, would it matter if I kept? It would matter. If you go on either side for the province, that would be a -1. Because you're going against the domain and range. You're saying if you go arrow ahead here, you're saying time can be negative. If you're going past this, you're saying that the stun continues. So we're kind of just restricted to this. One more thing, if you want full marks, then make sure this appears. 183.75x plus 1,080. And before we go, domain and range. This is question G. Domain, we're going from time 0 to 1960. Right, that's when the stunt ends. It happens right here. So you go down to the x-axis, it's 1960. My range, as low as 179.63, right? That's the lowest y value. And the highest is 1,080. So I want you to try page 50 and 51. I'll say this. If you don't want to graph because you're not so sure yet, I'm okay with that. But you should try to answer everything else, okay, on those 2 pages. It reviews regressions and will get you there.